Hi. So yeah, I'll give a presentation on this, and this is kind of building on what like we already said, I suppose, except I'm coming out from maybe a project management point of view, and also from Jacobs in Ireland, maybe it's mainly pharmaceutical projects. So this is industry, it's not commercial or residential. Okay, so I'll just give a very brief introduction to pharmaceutical, the strategies we use, all the while for sustainability and the digitalization and how important that is on our throughout the life cycle of the project, right, through that execution and the practice. So I have 20 years experience, chartered engineer. So that's what I've been working in pharma as well as other industries for a while. And I suppose one of the things, and this goes with digitalization, but also with sustainability, is George Bernard Shaw. I wasn't actually talking about projects, but as in, I think the problem with a lot of stuff is communication, and unless everybody understands what you think to tell somebody, this is always what they actually hear. So even on projects here, just a brief, how many people are involved in projects? All of these people, so what the board of the company, what the scheduler sees in the project is not the same as what the cost planner sees or the designer sees, etc. It's completely different. What's important to them, to the designer, is not the same as what's important to the consultant. So as in what I think this is a act for anybody involved in the projects here that we ask for steps and actually got the climate launch is now at the bottom right. So everybody sees something different, and this is why I suppose on projects you have a framework to try and get rid of all these inconsistencies in communication. Okay, so like I said, I'm involved in pharma, so I get a very brief introduction of people maybe currently involved in the industry. So there's actually two ways to make drugs. There's the traditional chemical way, which is API, and then there's a newer way, let's say the last 20, 30 years of biopharma. So living organisms, both of these are in Ireland. But one is with actual chemicals. We mix it up, we distill it, we boil it, etc., and it adds on to this. Whereas with biopharma, it's actually you take something from an animal and then you boil it up. You either want that cell or you want something different. You want the excrete. So if you can see here on the right is the traditional chemicals like Viagra and Torque. The NW molecular weight is only 667. So basically, you start off with a few chemicals, you add on a little bit, it adds on a tail, adds on another tail, step. So you get up with 667. But if you look on the left, which is a protein, the molecular weight is 150,000. So this is impossible to make with chemicals. So this is the wonders of living organisms. So basically, you take something, a cell from a hamster or a pig or whatever, and it starts very small. It's 1 liter, 5 liters, 50, 100. 20,000 reactor, and then you go from there. So that's how pharma works when you have in drugs. And so what you might get is what's actually in the cell might be important, depending, or maybe the cell excretes something like a protein and actually the filter for the. Okay, so I suppose what I'll go into here is strategies and then the digitalization. So in pharma, it's very the BIM model as was discussed earlier, and what part of that is very important in the pharmaceutical sector, and like how projects are done. So these are 5 different strategies from building the warehouse all the way up, and I'm going to just focus on how the digitalization comes in here for the EPCM model, which is the engineering, procurement, construction management. And then the second one is a slight variation that's called an IPD, but it's very similar to the EPCM. And just on this, what is basically what I'm concentrating is what I just said there in EPCM, which is top right, which is very large scale projects, but they're also complicated. So, you could have a very, very large warehouse, but obviously it's not complicated. Maybe some hotels, commercial are in the middle, but then when you're dealing with pharma or industry, you're getting very large scale projects, but also very complicated projects. That's where the EPCM model comes in. So EPCM, engineering, procurement, construction management, and effectively this method is that there's a big overlap between engineering, between the construction and the procurement. And the reason is this is schedule, especially in the pharmaceutical industry, drugs go off patent, etc. So as soon as it's approved, it goes through the trials. They want to start they can only make money once you build a plant and sell it. And this, there's only a shelf life for it. So as you can see, there's a high level of overlap between the design, procurement, and construction. And basically what this means back to the quantity surveyors procurement is that when we only go out with maybe 50–60% design, depending on the contracts, and then this then is on a reimbursable basis once actually the project or the contract gets signed, etc. And this is all then within, let's say, for our company, it's normally within one company, but it can be the EP, the engineering and procurement, which is essentially the design piece, can be one company, and the CM management can be a different one. So it's not always the same. And this is for to facilitate a very fast shipping. And the EPCM then, with the LPD is called more LPD, is that basically you get the construction contractors, which are normally only in construction, but they're engaged much earlier in the project. So they're actually part of the early design phase. So they're brought in much earlier in the design. And this obviously this means that you're ready to contractor, like whether it's civil or mechanical, much earlier in the design, but you only engage with contractors that you know are good, maybe you've worked with them before, and that you know they have the stick capabilities, etc. And what would happen there is you've gone schedule rates from the project you did before, you know, we negotiate. So as in, it's not as if they have to rebid it. You would already agree before they even start working what their reimbursable contract or what the rates are going to be. And this again is to facilitate a very fast project. And the BIM model is, and some of the digital stuff is integral to this. And part of, there is a small bit of a risk, but of course, when a contractor, let's say a mechanical contractor, if they do part of the design, then they can't go back afterwards and say it was wrong, which is like different from the other model. Somebody goes to design and then, okay, the pipe doesn't fit, we have to chop it and okay, that's another 200 draws. You know, and you do this 1,000 times. Whereas if they do the design for the client, you can't go back and say there's a problem because you are part of that, you are part of this. So just on the project execution process, and this I'm trying to use involving projects, know something or have something similar to this. Then feasibility, then concepts, preliminary engineering. So you've gone from a lot of options and narrowed it down to a single option. And on all of this disciplines, the detail design, construction, of course, and CQ. And what I was talking about earlier was that if you're doing, because of the EPCM model, you actually do some of the design really early, as in just when you've only kind of decided what you will do. If you want to start the construction very early, you obviously need to do your foundation, steel work, all that design needs to be done really early, so that you can go out to tender, which might take whatever 16 weeks, and then there's a mobilization, etc. So as you can see, that very detailed design and even steel, you need to allow for whatever 12–16 weeks just for it to be manufactured, prefabricated. And then for the IPD, like I was mentioning there, that in this, the mechanical or the civil, etc. contractor would do some of the design in BIM and Revit, big civil. And so they're involved not just in construction, but way back in the design phase. And I suppose if people aren't familiar with farm, I'll just give a brief overview of the type of duration. So this will be anything, what I'm talking about here goes from the project for 5 million up to 2–3 billion. Same process, same everything. So very large, very small. So typically small feasibility stage, then the concept stage, you'll get a report and there's a cost estimate. And this relates back to what was talking about before with the estimate. Sometimes you have the model, sometimes you don't, sometimes the design isn't available. So the VOD, a key phase, you're up to 30% design, but this is where you get your ±10% estimate, which is the control estimate for all the rest of the project. And the detailed design, they get 15 months construction, a big overlap with that. And then CQ. So between the detailed design, construction, and the CQ, there's big overlaps, which isn't shown here, but as I mentioned before, there's big overlaps with that within the project. So I suppose on the project life cycle then, like what software do we use in the pharmaceutical industry in Jacobs? So a lot of stuff I suppose we've mentioned already, but for most disciplines we would use Revit. And then Plant 3D is used for piping. And the piping is, we use isometric. So for every piece of pipe, for any important map, I don't need a bathroom, but for almost every other piece of pipe in the plant, we would this would be put out in a sheet with an isometric, and this would be fabricated before it's gone to site. So there'll be kilometers of pipe work fabricated in the building. They're fabricated, building might need to be built yet, and they expect that it just fits in like a jigsaw once you put it into the building. And then with this one, so I suppose obviously everybody knows that digital changes quite quickly. So like for us, Releaso is a relatively new tool. This is more for clash detection, much easier to use, which I have up there than Navisworks, let's say. So it's quite good, but it's also, you know, you have to try and get other companies to engage with it. If we're the facilitator and we're going to use it, well, we need everybody else to start using it as well. So this takes quite a while, but it's relatively new, only a few years. So let's obviously we were using Navisworks. There's plus and minuses, but we're basically on for some elements of it, not we're using Fred. And then we use Bluebeam for checking drawings, PID, that sort of stuff. Primavera, probably mostly for scheduling. And so we have JPI, which is just a Jacobs, but this that's what you get a doc management system. So this could be what's actually next, which is EDA. Not sure if people are familiar with this, but it's quite a powerful tool. I suppose mainly used on the construction side for submittals. That's that the contractors get in, we can comment on them, etc. And then it's approved and all that. And voyage control, which is site deliveries, flex manager, on-site training, and then Power BI for reporting. So I suppose if I came back in 5 years' time, this would probably be fairly different. But as in, these are the things that I suppose you don't need to be integrally involved from a project manager point of view, but like you need to know what they do, you need to know how to use them and also then all the different discipline leads, you need to know how they interact with each other, which can be complicated. And of course, there's other stuff like Comos, which some clients use that they want for, and then that they use for their maintenance, etc. So it's mostly this. And ACC, which came up previously, is also uses the documentation to it. And the sustainability element, then this is something that probably wasn't even on, like let's say, wasn't on our radar, whatever, 5, 6, 7 years ago. But now there's with quite a big department, and every client, this is what we want, and this goes from both embodied carbon, like it's in the building structure, but also operational wise, and how much carbon they're going to use on an ongoing basis. So I suppose some of I just listed out here, the high level settings that we come across all the time, and headings that we come across all the time. And like this, if we're back 5 years, I say nobody would know anything about this. And even some people in the company, because it's quite new, you know, okay, well, something sustainability will deal with that. I don't need to know about it, but it's so often every client now they have their own SOPs or checklists. We have our own checklists, so you need to merge them. So the green building rating. So this is something like these. So this is obviously a framework then for sustainability. The life cycle assessment was talked about earlier. So this is like just a calculation of the embodied carbon and also the operation of carbon of the project, not just what's you build it, but obviously going on, which is mentioned. Of course, everybody knows energy and water metering. You know, we want to use less energy, less water, and especially in pharma. You know, you use water to make water for injection, Wi-Fi, you use water for steam. So there is quite a consumption of water, but you have to treat the water before you use it. So any reduction in water and recycling of water is a big plus. The EU taxonomy assessment. So this is similar to the green building, except this is a financial tool. So this is also something that comes up, I suppose, all the time on our projects now. It's circular for zero. So it's just the supply chain, not what's actually goes in, but all the way back to. And this is for our sustainability. We have on the procurement side, we now have documents. You know, this is what we expect of our vendors. Every time you read something out, whether that's procurement, whether that's an equipment or a contract, like this document goes with it. This is what we expect. So even, you know, some clients, whether you're on construction, okay, so you want to use steel, but actually what type of steel do you want to use? You know, can it be made out of coal? No. Can it be made out of gas? Yes. You know, so even this, so like one client recently, we couldn't get steel from England because they used coal to make steel. So that's higher level of carbon than if it was made out of continents, etc. And green electricity, obviously this is obvious enough, but this can be on-site, you know, PV panels, but also off-site. So you can some big data center, which you've probably heard in the news, or a company can say, okay, well, some wind farm at Donegal, all that energy is mine. So effectively, my electricity is carbon free. And sustainability requirements for procurement, I just mentioned there. So there's now being demanded off the vendors. We expect you to comply with this if you want to supply equipment. And decarbonisation, obviously, for existing buildings, for those ones you want to try and make them have a reduction in carbon, but also for new buildings. So there might be some constraint on site, which you have now that what you need to allow for it. So, for example, there's no connection to the grid in the local area for new renewables, but that might be in 5 years' time to make allowance to that, so that you can settle down with it. Okay, so I'll just briefly run through then, like, I suppose what we do and how important the model is and the digital elements of it and through the different phases. So feasibility, this is a very small team, level 1 design, get a small documented lots of options, will it fit roughly how much it will cost, could we do it, yes or no. But so this is like a very rough PFD of waste. So like, are we going to truck it outside? Is it going to be neutralized? Are we going to mix it with something else? Is it going to go to artificial air, etc. The concept, then the team is getting bigger. And we then kind of agree on, or try to agree on major decisions, and especially the size of the site map of the building or the campus, its campus. And what technology are you going to be using? Electric boilers, steam boilers, simple things like this, but obviously very important over the whole project. Then you get a better level of the schedule, you have equipment lists, and then this is where a 3D model starts. So you have a site map, or sorry, the site master plan of where your buildings, talking about the campus, where your buildings are, what size they are, etc. And then you get, even this early stage, if it's a large pre-construction activity, so what's your construction strategy? And then the list of bidders that are going to be on that, it's really big. You actually don't want just one mechanical contractor, you might want 3 or 6 and you get a plus and minus 30% estimate normally. And so as you can see from the PFD, this is the next phase of it. It's a bit more detailed than the block diagram. The last one, you have, this is a code, just the layouts of the building. So if you move into base design, it's probably the most important phase out of all the designs. So again, the team's getting bigger and bigger up to this. It's basically you're building what you did the last time, except now there should be no more options. By the end of this phase, you know exactly what you're going to do at a high level, and the 3D model is integrally important into this. So it's not just let's improve that it fits, but that it's sorry, that that it fits, you might take something from somewhere else, but that effectively you're proving that for PLDs, concepts and instrumentation diagrams, which is it's just the basis of everything. This is when the basis of the process is in this PLD drawings, and everything else flows from that. So this is very important that these get actually this phase, planning permission, etc. And I suppose the model, like I was talking about here, the procurement cycle starts, and the model here then from this point on is where it comes into its own, I suppose, is that whichever cleaner leaves, like I mentioned after this phase, we can now start doing the modeling properly because the hypers know what they're going to be modeling. We shouldn't change too much. And then we go out with the vendor, what's why the procurement is so important. Is that we need the vendor to have it back, so you get out to the vendor, and then maybe 3, 4, 5 months later, they come back with a drawing. So this drawing then, or their first version of a step file for 3D model goes into our model, and then you can start doing your reviews. So this each review of the client, 30, 60, 90 is review of the client. So we'll go through every single pipe, PID, etc. Depends on the client somewhere very particular sometime. And this then is a PID that you get. So when you take from the first phase, the second phase to this phase, so this is then what pipe work, etc. or the modelers can use in order to see obviously lines in a diagram. One of those lines from one to a valve, from the tank to the valve might be 1 meter, or it could be 20 meters. But all needs to be under slopes, etc. So this is all needs to be coordinated inside of the bottom. And this there, you can see back to the sustainability. This is just a water mapping. So what's being used, the reduction of water, can we recycle more from the end back to the beginning, for example. And as I was talking there, as you can see, some of the ones up the top there, which is which is Waterford addiction is just quite a big use. So even from a process, if we can reduce the amount of time stuff is steamed, etc., then we won't need to we can reduce that. So I'll just show you some of the stuff down at the model that we're going here. This is a very large team. So, and like I say, on the with piping, everything has to be isometric. So on the large job, we've got maybe 120, 130 pipers just doing piping. That's all they're doing for 2 years, a year. So quite a lot. And so this is then you're finalizing the layout. So not just that the equipment works, but like if you've got a wheel in a pallet truck and turn the pallet truck around, can you do that? Do you have access to all the balance, etc. So just with the model inside the bin model, you can see on the right there, this is the model zone. So what I was saying of 30, 60, 90. This is then split into these areas. So this is just either by like it could be a room or it could be just a related area that's together. So for example, A is just an office, whereas D is a pipe. So it doesn't have to be, it's just whatever makes sense that you could kind of do together. And yeah, we continue on, like I said, with the dome cycle and with all everything else, EIDs, but it's basically just a continuation of what you did before about things. So just to give you an idea of the sort of items that we're doing to do with the bin elements. Yes, so this is so anything here, it's all built from scratch. There's nothing there before, and then this is all built like part by part. So in this facility, there was nearly 70 kilometers of piping that had to be modelled, and everything would have had to be isometric, and of course, reviewed before. This is just in a different facility, but this is just one room. So as you can see, there's quite a lot of piping, ducting, how compact it is. So this would be between the top of the tea room ceiling and then the concrete slab of blocks. It's probably only 1.5 meters or so that you would have to. So this is what takes all the time, all the coordination, etc. And this is where being Revit, but then Revisto comes in, that you can see the clashes easily. You can assign them to people, because if you're doing it, which is previously, if you went back a few years, it's kind of, you can run a clash report, but it's in Excel. Then there's a big manual exercise to have to like what was done, what the map on, etc. And you can see here then this is just below all the valves. So every valve is supposed to be accessible. We put some slopes in these lines and get up and down, etc. So quite a lot of coordination. And so that's why pharmaceutical projects take a long time to do. So this is just a run through, maybe a bit similar to what Michael had earlier. So this is everything was from scratch. There was nothing here before. So this is one 6-story facility. And then, so this is everything what I'm in here by the team. And I suppose this is where understanding how Revit, BIM, Revisto, Plan 3D all fit together is quite important. So some of those skids on the right-hand side, that's pipe back above. Some of the skids on the right-hand side of the come from vendors. Obviously, we have to dictate what where stuff goes, where it comes from, etc. So just moving up here, so this is part of the pipe rack. And the white is structural steel. Then moving up onto the next floor. So this is part of just a clean room. So this is above the clean room ceiling then, as you can see how many pipes there is straight above the clean room ceiling for coordination. Maybe that's about a meter up to the following floor then, just to if you do the course in MTU, welcome. So any pipes you see there, they have to be coordinated so that they can be built off-site, and then they just get into the building. Okay, so this is just on into construction now. So this overlaps a lot from detailed design. So as I mentioned earlier, about some off-site modularization, off-site manufacturing. So this also happens here because these to be mentioned well very early in design and needs to be decided whether there's pipe racks, data rooms, smart shelters, etc. are built off site and then brought into site and at what stage can they be brought into site. So obviously it's quite important that it's quite beneficial in some ways, as long as it's local, especially pipe racks. Takes a lot of the health and safety items out of off the site. And so then, like, as in some of the standard construction stuff, logistics, handover, turnover packs, etc. So I'll just go into, obviously we don't want any change. It's very important that the construction stage. So some of the other elements that we use then again is this here. So this is what we use just to show how the schedule and the construction interact. So that the construction is from left to right. So this is all pre-works, and then it starts. So from 5 months out, then up to one slide up to up into the chambers. So this will be a full campus.
What's the value of that job be?
This well, this is from scratch. So this is a very large project. This will be over 2 billion. And most of the, not all, but obviously the size of the buildings are very big, but like most of the value, if you say on a square meter basis, is in the production buildings. So there might be 1 or 2 production buildings. So depending on whether they're actual production, which is like making the pharmaceutical ingredients, would be very intense with piping, with the value of the equipment, etc. But some facilities then, that's actually making the active ingredient. There's some of the other some of the second phase then is you have the active ingredient and you either want to put it in a syringe or you want to put it in a tablet, etc. So that could be and then they package it. So there's a fill finish facility which wouldn't be as complicated. There might be one building might put it into a syringe and then they get packaged. So this will be much less, but the buildings won't be bigger. And the last stage, which I suppose most people forget, along with is the commissioning and validation, which is quite a long operation. And this overlaps with construction. As soon as construction finishes one system, you can press there for the first, then it moves into the commissioning validation stage. So commissioning is, I suppose, what anybody goes on any project, and then the validation is to make sure that it does what it's supposed to do every time. So qualification and validation. And there's this the V-shaped model, which is that's those what you plan on there, and then you do your PQ the right hand side. And then that's
Very good, Ross.